So let's recap. Chatbot, very clever, but you talk to it, you have to tell it everything. Agentic AI, the chatbot has now access to your tools, to your files, and it can do actions in loops. A complete jump. And then skills. Skills help you automate and put guardrails on that agentic raw power. It can control the variance. It can make process more repeatable. You can evolve the environment over time. And what is next? This is something less popular. It hasn't yet got a unique name that has broad consensus. Some people call it knowledge base. We tend to you find it like domain knowledge. Sometimes it is put within skills. The idea here versus skills is that whereas in skills you were trying to to write about intent, so to automate the intent of certain piece of code, here you are trying to build knowledge. You are trying to get feedback on what worked earlier, get feedback on nuances or certain model, etc. Let's see how this looks like. By the way, before we start that, I'm curious to see if our Cloud desktop finished. Yeah, well, it's a bit silly, but the latest thing that I had was a QR. It has created that little animation. But yeah, the idea here, remember, was that there are already many tools for you to try agentic AI locally. Back to the presentation. We are at the level 3. What is domain knowledge in the context of AI agents? These are markdown documents that the agent can load on demand. And it carries the judgment that the code base doesn't necessarily have. So this is at the plan level, at the decision level. It gathers knowledge and experience over time. So this is a way to track failures and ensure it doesn't happen again. It's a way also to ensure diversity in what you try. How does that look in our graph? From the previous level, we have the agentic implementation plus skills. And now in this reference folder or knowledge base, domain knowledge, however we call it, we have some new readmes. These markdowns, again, has some metadata, just like the skills that the system has access to decide whether they could be worth pulling. And then on demand, they will be pulled. The main difference here is that the feedback loop updates them very frequently. The objective of this, as I was saying, the objective of this new level is to gather knowledge more than automated code. This is an interesting essay, very recommended by Michel Hashimoto, that talks about this. And how does this look like in our actual example? So you see, we've created some anti-patterns markdown. It has a description like with the skills, common ways. But look at what it says, common ways that prior work on this task has gone wrong. Check this because most of them are not obvious from the data alone. So we have captured from previous intent traps that we failed on before. Or protocol for naming alternatives before committing to one exploration discipline. This is basically about enforcing variety in what we are trying. So not just going through one route and optimizing that and ending up in a local minima, but actually trying to try different branches of options. This is what this MD is trying, and to do so is keeping track of what we've tried and how we've done it. And here we have dynamics formulation, similar on how to actually improve on the physics of the model complexity. As you see, we have several. Let's see how they did. Well, just before we do, as earlier, I'm gonna show you how a template like that looks like. So you see, we still have our code, data, skills from earlier. Now we also have references. These are MDs without code, and yet, as you'll see, very effective, really important. Patterns to avoid, approach menu, so where to start from, how to mark things as explored or not. One way to see this is that we are assisting the planning with memory. We are allowing the model to gain experience on the actual problem. And now let's see the results. As earlier, we launched 10 agents with these conditions, same prompt as in level 1 and level 2. The only thing that changes is that now the environment has this knowledge base. And these are the results. Huge improvement. These are the latest agents from the level 3 versus the previous level 2. We can also plot level 1 and the baseline, and you see that we've achieved a really good improvement in performance, and also, very interestingly, we seem to be converging in the same solution. So it seems that we have a capable enough solution so that we seem to be achieving the global optimum. On that variance things that I said, you can see that most of the agents achieved the same solution. And where does that take us? Let's think again in the ladder. So we started by level 0. We compare it with level 1. In level 1, we have implemented the agentic AI. Super capable. It has already improved the model a lot. Anything from this point will be harder, obviously, but we've achieved that. Locally, it's really easy to try. You can do it. Harder in a production environment. Then we try level 2. We implemented skills. It took the average performance of the agent-produced models a little bit further. It decreased the variability, so all looking good. And then knowledge bases, not that popular on the internet, but a move that helps a lot, we found with assisted engineering. And it has worked here as well. We see a very good improvement. It's hard to keep improving that way where we've already covered most of what it was achievable. And also the variance got better.